Welcome to You Can Do It. I'm your host, Chris, and in this episode, we're continuing the construction of our greenhouse. And today we're going to be taking apart this fence. This is our back line, our property line. It's actually just on the other side of the fence. It's not right on the line, but our back wall of the greenhouse is going to be where this fence is. So we're going to be taking the fence down from here, about 4 posts down, and that'll be the last section. So this whole section is going to come out. We're going to try to repurpose some of these fence boards for some siding on the greenhouse, and we'll show you how we end up doing that.
Okay, I'm going to show you the Pythagorean Theorem for squaring any kind of building. This one's rectangular, doesn't matter. Square, rectangular, this theory works on both. The Pythagorean Theorem is a squared plus b squared equals c squared. These are going to be your known sides, A and B, and C is what's called the hypotenuse. I'll show you that in a second. So here's my building. Here's one of my far end posts, and here's my other. These are made of steel. So what I'm going to do is I am going to measure interior from steel corner to steel corner. And then of course, if this is my back side that we're just now putting these posts in, that is also going to be the same measurement, steel interior post to steel interior post. That happens to be 291 inches. So I'll write that down. And then interior again, from interior steel post to interior back steel post. And that particular measurement is 76 inches. 76. Now the way the Pythagorean Theorem works is the crossing points from interior to interior need to meet at the exact same cross point for us to guarantee that this building is square. It does not matter if I call this side A or if I call this side B, this side A or I call this side B. What does matter is this interior angle to angle or corner to corner is always going to be C, which is called the hypotenuse. So I'm just gonna, for this purpose, call this A, and this side's A, and this side is going to be B. So in order to find A squared, I multiply this number by itself. So when you square something, it is literally that to the second power, but because I want to use this simple calculator to show that anyone can do this, it's number multiplied by itself. So 76 times 76 equals 5,776 squared inches. Okay, and that's inches squared. It doesn't really matter for this purpose. We don't need to get into that part of the math. And then now I need to square my B. So always zero out your calculator. So that is 291 inches times itself, 291 inches. And so the squared value of B is 84,681 squared inches. These two added together equal my C squared, which is this side right here. So I'm just now going to zero out my calculator and add these two values together. So we have 5,776 squared inches plus 84,681 squared inches. We come to a value C squared equaling 90,457 squared inches. Now that is a squared inch value. So in order to get the actual across value, I have to take what is called the square root of that number. And what that means is what number times itself equals 90,457 squared inches. Even standard simple calculators have a squared inch button. So with this value in here, all I do is push that square root button and I come up with 300.760. I always go to the hundredths place. So this is your tenths, this is your hundredths. Because this is 0, I don't round up. So this entire hypotenuse here is 300.76 inches. That's how long interior corner to interior corner, and interior corner to interior corner. So .76, that's 3/4 of an inch. So in theory, this is 303/4 of an inch long. That still doesn't get me to this final number right here. Where does this and this cross? So in order to find that, I just divide this in half. So I'm going to zero out my calculator and put in 300.76 and divide it by 2, which means I'm dividing it in half. So this hypotenuse and this hypotenuse are going to cross each other at 150 inches, .38. .38 is a little over 1/3 of an inch, so if we're off by a hair, I think we're okay. So when I lay out my measurements for where these posts are going to be to square up this building, I need to make sure from here to here, I'm exactly 76 inches. From here to here, I'm exactly 291 inches. And then where this line crosses and this line crosses, it needs to be 150 1/3 inch. And then that guarantees that I have a perfectly squared building, and I'm not going to have to graft in any weird slivers of wood in order to square my building or to fix the mess I made. And remember, this is done on the floor level. As a building goes up, it gets worse. So you really want to make sure, just like you've heard, your foundation is key. You want to make sure that you start off with a squared building. So as you go up, you're not going to have basically a telegraphing error exponentially grow as the building gets taller. So I hope this helps, and we're going to go outside and put this theory in.
Hey guys, so it's been about a day now and I wanted to take this off a lot sooner, but just with all the things we've been doing here lately, this form has been on here for a little bit too long, but we're going to go ahead and take this apart. I want to show you kind of how it was assembled, but I'm going to start removing the clamps. As you can see down here, there's some all thread and some nuts and fender washers. I found that when I did the first panel, it started to bulge, so I was trying to keep the form of the panel being 4 inches wide all the way through. This area down here is going to be covered with dirt because our bed is going to be up about 24 inches. But I'm going to go ahead and pull these apart. So I bought some all thread from Home Depot, came in a 10-foot stick here, and I just cut it to the proper length that I needed, ran it in, and then put the nut and washer on both sides to keep the panel at 4 inches. So I probably could have done a few more. So if I was to do another one of these walls, I would probably space them out maybe every, I don't know, maybe 2 feet or so. But I just noticed that as I was pushing the concrete up and down inside the form, it was pulling the form boards out a little bit. So if this was actual form on a house or something, yeah, I wouldn't be happy with it, but I'm actually really happy with the way this turned out. So let's go and start taking apart get these nuts taken off here. I got a 3/4 wrench, and I'm gonna take all the nuts off, get everything ready to pull the panels off here.